Using optimization and deep learning for complex problem solving. Comprehensive review. Prepared by master student Zainab Sami Al Ibrahimi. Supervised by Professor Dr. Samahir Al Janabi. Outline. Introduction. Problem statement. Related works. Research methodology. Objectives. Reference. Introduction. Data science is discipline that combines concepts from computer science such as algorithms, programming, machine learning, and data mining, mathematics such as statistics and optimization, and domain knowledge such as business application and visualization. 2. Extract insight from data and transform them into action that have an impact in the domain of application in question. This slide compares between data analysis and intelligent data analysis. The stage of data analysis is actual or virtual problem, understanding this problem, understanding parameter of this problem, and data preparing, design model, and final stage evaluation model. While the stage of intelligent data analysis is real problem understanding parameters and design and evaluation models, final step and three-step interpretation of results. Problem statements. The problem of this work divided into two parts. The first part related to programming challenge, where all deep learning techniques suffer from multi-drawback such as high computation based on try and error to determine parameters, need to high time implementation, but it gives high accurate results that represent advantage for deep learning technique. We can solve high implementation time drawback by using Grey-Wolf optimization algorithm, while the second part related to application challenge represented by find maximum amount of DC power. In the next 5 slides, we mention 10 previous work related to our work. Research methodology. The proposed methodology constructed from 5 major stages. First stage, preparing and pre-processing data. In this stage, dataset that collected from multi-sensors are cleaned by drop missing value. Second stage, find most effect features. In this stage, apply Grey-Wolf optimization algorithm to find most effect feature. Third stage, redundancy of most effect feature dataset based on Grey-Wolf optimization. Apply Grey-Wolf optimization algorithm on dataset that obtained from previous stage to compression data as possible. Fourth stage, prediction using gate recurrent units. In this stage, gate recurrent unit technique is applied on dataset that obtained from third stage to predict wind power. Final stage, evaluation result. By using multi-evaluation measure, will evaluate the results. Represent the rate between the compression and accuracy rate include rate of data compression based on drop missing value, rate of data compression based on most effect feature, rate of data compression based on buffer of different group, and the accuracy of the three datasets. Spatial wind power forecasting datasets that represent original datasets, most effect feature datasets, the buffer different group Grey-Wolf optimization datasets, in addition to compute the return energy measure. Diagram, we explain the step for making the proposed method. First, we test the original data whether it contains missing value or not. If it contains missing value, it enters the first stage and drop missing value. Then the result data set is stored in buffer. This stage called preparing and pre-processing. But if the original data doesn't contain missing value, that will go directly to the second stage. The second stage is find most effective feature by a Grey Wolf optimization algorithm, in which the data resulting from the first stage or the original data is entered if it doesn't contain missing value, and the Grey Wolf optimization algorithm is applied to it after specifying the fitness function and main parameter of the algorithm. The resulting data will be stored in a buffer and called the most effect feature dataset. In the third stage, we in the in the third stage we reduce the redundancy of most effect feature dataset by Grey Wolf optimization algorithm so that the output of the second stage most effect feature dataset are entered as inputs for the third stage, and the Grey Wolf optimization algorithm is applied to it after specifying the fitness function and main parameter for the algorithm. The resulting data will be stored in a buffer and called buffer of different group dataset and buffer of different group dataset, and in other buffer will store the frequency of each sample. While in the fourth stage, do prediction based on get recurrent unit technique, and the dataset that resulting from the previous stage represented by buffer different group dataset is entered into this stage as inputs, and get recurrent unit is applied to it as well after specifying the basic parameter and also objective function, and result of this stage entered to final stage, which is the evaluation measures stage. Objectives: investigation the ability of Grey Wolf optimization algorithm and find the most effective feature to prediction the DC power. At the same time, reduce redundancy in the dataset through grouping dataset into multi-interval and compute the frequency of each interval. Employment the capability of one learning algorithm called gate recurrent units to work on different size of datasets, such as spatial wind power forecasting datasets, most effect feature datasets, buffer different grouping, gate Grey Wolf optimization dataset, and forecasting the DC power. Test the performance of using different measures represent the rate between the compression and the accuracy rates include rate of data compression based on drop missing value, rate of data compression based on most effect feature, rate of compression based on buffer of different group, and the accuracy of the three datasets: spatial wind power forecasting dataset, most effect feature datasets, buffer different grouping, Grey Wolf optimization dataset, in addition to compute the return energy measure. In this slide we mention the reference used in our work and in this presentation. Thank you for listening.